and welcome to the MFG Advocate on IMTS TV. I'm Penny Brown and really excited today to be talking to a panel from Oakridge National Laboratory. With me today I have Roderick Jackson, Bill Peter, and Scott Curran, and this is the group behind the Amie project, the Additive Manufacturing Integrated Energy Project, making a big splash at the front of North Hall at IMTS 2016. So let's start with you, Bill. Can you give us an overview of this project?
Morning, Penny. Yes, I'll be glad to do so. So I'm Bill Peter. I'm at Oakridge National Laboratory. We have about 4,500 people at Oakridge that are looking at everything from fundamental to applied sciences. And as we go through and look at the integration of some of these different areas like transportation, buildings, manufacturing, the grid, renewable energy, Amie, which stands for Advanced Manufacturing Integrated Energy, really was trying to pull each of these together and start looking at how we can think of these things differently as we start to integrate them and pull them together in new areas.
Now, I understand this project pretty much took just a year from concept to launch. It's pretty amazing.
It did. It was a very rapid project as you started looking at some of the different aspects in design and having local companies like here in Chicago, SOM design the building, and then going through printing out the building itself as well as the car that helped to integrate and look at the overall energy picture.
All right, well, let me throw it over here to Roderick. Now, how about that building? That's pretty amazing, 3D printed. Tell us how that's done.
Wow, so my name is Roderick, as I alluded to earlier, and I lead our buildings research as part of the Amie project, and also I was a technical lead for the project to say, how do we bring this together? Really, it started, I think, 2 years ago at the IMTS, where at the IMTS, the 3D printed Strategy was the first car that was printed here. And from that, there was a thought, well, what if this was applied to buildings? What if we took that excitement and the innovation that we saw in the Strategy and brought that to buildings to really transform how we look at buildings? Because we've been building buildings literally the same way we built them for centuries, you know, with sticks and blocks and boards. So the question is, what can additive do that we couldn't do before? How can we totally wipe the slate clean where whatever makes sense, that's what we do? And so what did we do? We brought the best in the game. We brought SOM, located right here in Chicago, to the table to say, if you could have a clean slate and design a building as a building was meant to be designed, using additive as an approach, what would that look like? And then you bring together the MDF folks at the Manufacturing Demonstration Facility and their expertise, world-class expertise, world-class facilities, and say, well, now let's look at the building. And let's see, now we can start doing organic structures. We can look at curves and reduce the amount of stresses that build up when you have straight walls and corners. Use new insulation materials. Wow, just it's exciting. I kind of hold my excitement, but just the opportunities that are there, and this was the beginning. And then we looked at integrating. What if the building could share power with the vehicle? And so that's where the integrated energy came in, where the building and vehicle share power. And so my colleague Scott could talk more about the actual car component.
Well, that's what I was going to ask you. You know, how, from a construction standpoint, how does an additive process have an advantage over, say, conventional construction?
Well, so a little bit about me. My dad built houses. His 10 brothers built houses. I grew up building houses, and we haven't changed how we build houses. We are limited by the materials that we use. We use wood or we use studs, and it really limits what we can do. And the first part of the whole process was we can't bring additive to try to do what we've been doing. Let's do what we should do. And so we had to first remove all the constraints. So additive allowed us to literally, if you could design it, you could print it. And so now some of the features that we thought we couldn't do before, we can do. We can start looking at, well, what if we actually could reduce waste? We've all seen new construction sites. You've seen that dumpster of waste material. Instead of dumpsters, you had waste buckets. So imagine that, and you know, as we look at it for a sustainable future where you have waste buckets of waste, or even less, instead of those dumpsters of waste, and what that could look like in the world, and then even look at emerging economies. Mm-hmm. If you could literally print on site using materials that were available on site, what would that mean for the next development in Africa or India, right, or places like that? So those are some of the what ifs. We just wanted to put it out there so all the innovators could see what's possible.
Sure, yeah, it's exciting to see how these things end up developing, you know, years down the road. All right, so let's talk about the vehicle here. So Scott, I understand that was your part of the project. Tell us about that.
So rising to the challenge that Bill mentioned on trying to tie manufacturing, buildings, and vehicles together. On paper, we knew what kind of vehicle we wanted. We know buildings have natural gas and electricity coming in. And those are both fuels or energy sources that we can use with a vehicle. And designing something on paper and getting a working vehicle, that's an expected challenge. It takes time, energy, and effort. Where the additive manufacturing really gives us a leg up on rapid design and rapid innovation is we can design something in computer using our normal research skills, and then we go to Bill and we print exactly what we wanted. And it's a functional, usable piece. So it's really this wild, wild west mentality of we get to print something functional that we want, and then we can build around the technologies we want to do. So we want to communicate energy with the house, so we can use wireless power transfer, and we can go back and forth with the bi-directional wireless. We can store natural gas in the vehicle. We can come up with new, interesting range extenders that can power both the vehicle and the building. But what the additive allows us to do is, whatever we want in that vehicle, we can build around what we wanted. So that's the really interesting and exciting part of that.
Now, do you think that's going to have an impact on, say, conventional auto manufacturing sometime in the near future?
So we're starting to see startup companies like Local Motors already talking about customized parts, customized bodies using 3D printing. I think you have one of the ollies here at IMTS. So that's really, one of the first commercial senses that we're getting. But then the idea from the research and design engineers. So instead of doing a normal body in white, starting with clay, then building a steel structure to do a rapid prototype, where I'm really excited is how can this large-scale additive really accelerate our prototyping abilities. So if we want to try something interesting like a novel fuel cell or something else, but we can print around that.
I think it's important to say that there's already some vehicle companies that are already starting to look at prototype technologies and additive and go through and actually test out their systems by doing so, especially in the areas of like engine fabrication and evolution. One of the other areas that we get very excited about is the die and tool industry. We have a lot of people that visit us at Oakridge, and one of the big issues is what's happened in die, tool, and molding. They've lost essentially 37% of those companies here in the United States. And so as they start to look to see what additive can do, it can go through and create tools very quickly at very low cost. And so bringing down the lead time, as well as looking at the scenario of reducing cost and going through and starting to produce parts.
Now, since you've been here at the show, what are people saying when they stop by?
They want to know all the different details, understand the integration. I do want to say one of the important part is this wasn't just based with Oakridge. I mean, we had 20 different industrial partners as we went and put this together. So it's really highlighting not just what we can do, but also highlighting what all of those industrial partners can bring to bear on these problem sets. But yeah, a lot of different questions on how we went through, what parts are printed, what parts aren't, and really trying to understand where are the limitations, how fast were you able to print, and what time, what materials did you use to print it?
Sure. Yeah, and we'll give a mention to Local Motors too, because they have a great site here, back of North Hall C. You can come see Ollie, you can come see the 3D printed vehicles, lots of exciting stuff. Glad to see those innovations. Well, thank you, everyone.
Well, can I add a couple things? Because I think he mentioned, when he said the 20 companies, we had companies that had never thought about working together, like SOM and Clayton Homes and True Design. So a big firm that's world-renowned, builds the world's largest, tallest buildings.
Sure.
And a firm that located in Knoxville, Tennessee, that builds manufactured homes. The two come together, actually work together to come up with Amie. And then True Design and then other companies. We did all this, brought those companies together in 9 months. That shows what additive as a tool for rapid innovation really allowed us to do with Amie. So I just wanted to double down on that.
Collaboration is the way to go, and I think we're seeing a lot of that here at the show. Really exciting, developments in all facets of industry, really, not just manufacturing. Well, thank you, everyone. It's always exciting to see what Oakridge does. I mean, you're going to have to top yourself in 2018, so you better start thinking about it now. All right, everyone. Well, if you're here at IMTS, be sure to stop by the front of North Hall to meet Amie. Very, very cool stuff. Thanks, everyone. This has been Penny Brown for IMTS TV.